The ASME medal is awarded to Dr. Jan D. Achenbach, Distinguished McCormick School Professor Emeritus in service at Northwestern University in Evanston, Illinois, for his groundbreaking contributions to the theory and applications of waves in solids, particularly in the ultrasonic range, applied to acoustic microscopy, dynamic fracture, and laser-based ultrasonics. Professor Achenbach is also being recognized for pioneering ultrasonic methods for quantitative, non-destructive evaluation and structural health monitoring. In the 1950s, Jan Achenbach was a young boy in the Netherlands who was passionate about airplanes. Eventually, he was driven to pursue a career in aeronautical engineering.
And I studied for about 3 or 4 years until a very significant event happened. The Soviet Union put the Sputnik into space.
That event launched the space race and changed the course of Professor Achenbach's life.
Did my graduate work at Stanford University, basically as a member of the Sputnik generation. Finished in 1962, spent a year at Columbia University as a postdoc, and then I came to Northwestern University, where I've been ever since.
At Stanford, he became interested in the subject that would shape the rest of his career: the propagation of sound in solids, especially materials like aluminum and steel.
Sound can enter a metal, and it can actually see inside the metal. And if there is a flaw inside the metal that you cannot see from the outside, you can make an image of it by the reflection and the scattering of that sound by that flaw.
Professor Achenbach's work on ultrasound has been used to detect structural flaws, such as fatigue damage in this Aloha Airlines 737, which led to the separation of the upper fuselage at 20,000 feet.
Well, we had to figure out why cracks developed, why corrosion developed. Then we had to figure out why these cracks would propagate. And then we had to figure out how we could detect those cracks, or that corrosion, or any other flaw or defect that might occur in the material.
Professor Achenbach's innovations continue to be used to detect flaws in airplanes and other safety-critical structures, such as nuclear reactors, bridges, and pipelines. He urges engineers at the beginning of their careers to work on finding creative solutions to significant problems.
I would like to tell the young engineers to get a very sound core knowledge in their field. And that core knowledge will allow them to consider working on a diversity of problems. And I would advise them to use their own mind to determine what is most interesting and that they think they really have a good chance of finding a solution for.